Hello.
Hello, sir. Good evening or good morning for you.
Good morning.
Yeah. So we will be starting just in a couple of minutes. Do you have anything to check before that?
No,
Connection
so
or
I just need to finish in about 45 minutes because of another commitment. I'll try to make it half an hour and then we can allow. Do you want me to allow questions or how do you want?
good evening or good morning for you. I'm getting a feedback, sir. So we will be
Sorry, I cannot hear you. Can you speak up?
Do you have anything to check before that?
I only hear background noise. I don't hear you. 45 minutes because of another commitment.
I'm really sorry for that, sir.
Okay, I asked the question. Would you
Yes,
mind
sir.
answering?
So yes, sir. No, that is no problem. We can start immediately then.
No.
Before,
I asked, my question was, do you want me to allow questions from the audience or not?
I guess we can do without that because I guess the presentation is more important.
Okay. And so how many people are joining us?
I think there are around 40 to 50.
Okay. Okay. So so you don't want me to leave time for questions?
Yeah, that is all right. What do you prefer? Would you like to? Would you like?
I'm happy to hear questions, so I can make it
Okay,
half an
okay,
hour
sir.
and then allow questions. Okay.
Okay, then we'll go with that, sir.
Okay, sounds good.
Okay. So before we start, I'd like to introduce you to the audience.
Please go
So,
ahead.
welcome to this lecture. This is the final lecture of Cosmic Voyage 23, and for that we have as the concluding guest, Mr. Avi Loeb, Professor Avi Loeb. He is the Frank B. Baird Professor at Harvard University as the Professor of Science, and he's had a lot of achievements in his career. He's also the best-selling author in very many lists, among which is the New York bestsellers list. And after that, we also have his work aimed at cosmological and theoretical astrophysics, and he's worked in many exciting topics like black holes and the first stars and early universe and many other topics as such. So without further ado, as he's also short on time, we can jump right in. So you can take the stage, sir. I'll make it.
Thank you, but I need you to allow me to share my screen.
Yes, sir. Okay, I'm sorry. So I guess you can share your screen now, sir.
Okay, sounds good. So very nice to meet everyone. Let me just, are you able to see my screen right now or not yet? Can you see my screen? I hope you do. Okay, so I will speak for about half an hour and allow you to ask questions because that will be the most interesting part of the conversation. So let me start. What I will be describing is a new frontier, which is searching for technological objects near Earth that could indicate the existence of other technological civilizations on other planets beyond Earth. And I had a book about that called Extraterrestrial. You can see the cover in the middle. And I also wrote a textbook together with my former postdoc, who originally was born in India, Manasvi Lingam. It's called Life in the Cosmos. You see it on the right side. And on the left, what you see is a photograph that was taken in my office by the German photographer Herlinda Quilbel. She asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, are we alone? And by now, I'm addressing this question with a large research group of about 100 people, part of the Galileo project that I'm leading, and I'll describe more of it in a few minutes. Let me skip over this so that we save some time. This will be just a brief introduction to the Galileo project.
It's such a great privilege, such a pleasure to see 70 members of the
Okay, I'll skip over that so that we save some time. So what do we know by now? We know that about half of all the sun-like stars host an Earth-sized planet, roughly at the same separation. And the numbers vary between 3% and 100%. There is a large uncertainty, but it's clear that we are not privileged or unique in having the Earth-Sun system. So altogether, there are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. So when you see a painting of a king like this one, who was very proud of conquering a piece of land on Earth, that's not more impressive than an ant hugging a single grain of sand on the landscape of a huge beach. So we need to have some cosmic modesty, but we didn't start that way. We thought that we are at the center of the universe. And the way I understand it is from my daughters, when they were young, they thought that the world centers on them. And then their view changed when we took them to the kindergarten and they met other kids, some of which were more smarter than they are. So the question is, are we the smartest kids in our cosmic block? That's the fundamental question. And if not, we can learn from other kids. Our civilization will mature by finding others. And my point is that Albert Einstein was not the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. What you see here is a cartoon of that was drawn on the day that Einstein died. It shows the Earth with a plaque on it saying Albert Einstein lived here. But surely there was a smarter scientist on another planet somewhere else that predated Einstein by billions of years, because most stars form billions of years before the sun. And that gave a civilization that was on that planet enough time to launch probes that could have reached us by now. And so the important point is that you can, in principle, send probes that have artificial intelligence so that they would be autonomous, and they will not be bored over a journey that takes millions or billions of years. And the question is, do we live in a reality where such probes may have arrived at our doorstep? And the answer is, in order to find out, we need to look through our telescopes. It's not a philosophical question. We can just look up and check the objects that are passing by. And we don't want to repeat the mistake of philosophers who argued 4 centuries ago that the Earth is at the center of the world, of the universe, and they refused to look through Galileo's telescopes and put him in house arrest. Now, which objects did we see from outside the solar system? It turns out that only over the past decade, astronomers discovered the first objects from outside the solar system passing nearby. The first report was an object that was given the name Oumuamua, which means a scout in the Hawaiian language, because it was discovered by a telescope in Hawaii in October 2017. And it was roughly the size of a football field. At first, astronomers thought it must be a rock from another planet, from another planetary system. But then it started showing all kinds of anomalies that cannot be explained, and I'll describe them. But it turns out that the very first interstellar object that came from outside the solar system was identified in 2014, almost 4 years before this one. It was detected by US government sensors, and together with my student, Amir Siraj, we identified it as interstellar, coming from outside the solar system. And our discovery was confirmed by the US Space Command in a letter that you see on the left. They say that at the 99.999%, indeed, the data from their sensors confirms that this is an interstellar object. And it was roughly 0.5 meter in size, slightly bigger than a large watermelon. It exploded in the lower atmosphere of the Earth like a meteor. The reason we could see it is because it created a fireball. And there were three flares in this explosion. And from the elevation where the explosions took place, we could infer the material strength because the object was able to maintain its integrity down to the lower atmosphere. And turns out that it's actually an outlier in terms of its composition. It's tougher than iron meteorites, and it's tougher than all the other space rocks in the same meteor catalog, 273 of them. And it was moving at 60 kilometers per second outside the solar system, so faster than 95% of all the stars. So that makes it quite unusual. And the question is, why was it made of a material that is so tough? It's possible that it was a spacecraft from another civilization. And in another paper, with two of my students, we calculated the expected distribution of fragments from this object that one can look for at the explosion site. It's in the Pacific Ocean, not far from Papua New Guinea. And it depends on the composition, of course, whether it's iron or stainless steel. And then we found another meteor in the same catalog just a few months ago. So we call them IM1 and IM2, Interstellar Meteor 1, Interstellar Meteor 2. These are the first two objects from interstellar space, because the second one was also discovered before Oumuamua in March 2017. And both of them are very tough based on the explosion.
My name is Avi Loeb, Professor of Science at Harvard University. In the coming months, I'm going to lead an expedition to Papua New Guinea to scoop the ocean floor and search for fragments from the first interstellar meteor.
Although Avi is in search of what he believes may be alien technology, proof of extraterrestrial existence has never been what's driven his life's work until now.
I'm hopeful we will find something. The question is, what is it? An unusual rock, a natural object, or artificial?
Despite being the longest serving chair of Harvard University's Department of Astronomy, it wasn't until recently that he started to investigate the possibility that there is life beyond our solar system.
I found the catalog that the government compiled of meteors that were detected by government sensors that are missile warning system. I asked my student to check if any of the meteors, the fastest moving meteors, could have arrived to Earth from outside the solar system.
There was one in particular that sparked the interest of Loeb and his students, Amir Siraj.
We decided to write a paper about this meteor, which was discovered on January 8, 2014. Light from the explosion was seen by government sensors.
Despite the government releasing limited data, he had discovered something groundbreaking. His paper laid out what he believed to be true. But 3 years after writing his findings, a major development confirmed what he knew all along.
After a few years, the release of a letter from the US Space Command in the Department of Defense stating explicitly that this meteor at the 99.999% confidence level came from outside the solar system.
Based on the speed of the meteor and how much of the object burned upon entry, Avi determined that it must be made of a material that is tougher than iron.
And so this one was an outlier in terms of its composition. It was also an outlier in terms of its speed outside the solar system. It moved at least twice as fast as stars move relative to the sun in the vicinity of the sun.
Armed with new evidence validating his findings, Avi decided to take action and make moves to recover the object, his next hurdle. Funding through private donations, he has secured a portion of the money to take the trip.
Let's continue to look for objects like it. It was obvious to us that we need to go there and collect the fragments, because to do the same thing for an object in space would cost more than $1 billion. For a cost that is 1,000 times lower, we can go to the ocean floor and collect material from an interstellar object.
Now, Avi has the task of finding an object that most likely fractured on impact, leaving fragments possibly the size of pennies lost at the bottom of the ocean. It's a challenge that might seem insurmountable. In the vast existence of the Pacific Ocean, but Avi is confident they will recover what they are in search of.
It's a fishing expedition, literally speaking, and what we can do is basically take the trajectory of this meteor and extrapolate it all the way to the ocean surface. Now, of course, when the explosion took place, there were fragments generated and they were scattered over a region. One imagines that the tiny pellets would be carried farther away from the point of impact, whereas the heavier fragments will sink down closer to the impact. Finding a big chunk can inform us much more about the structure of the original object. We're planning to board the ship and build a sled and a magnet attached to it that will scoop the ocean floor, and we will go back and forth like mowing the lawns across the region 10 kilometers in size and collect with the magnet all the fragments that are attracted to it and then brush them off and study their composition in the laboratory. This will be the first time that humans put their hands on the material that makes an object that came from another star.
With more advanced technology in our skies than in any other point in history, new findings are becoming far more frequent and impossible to ignore. Thanks to a government report that was released last year, the possibility of extraterrestrial life and the pursuit of proof of its existence is finally losing its stigma.
The stigma has been reduced. It would be the most important scientific discovery that humanity ever made, because if you think about it, it will change our perspective about our place in the universe.
With science in his corner, this professor is not intimidated by critics.
It's not a philosophical question whether we live in an environment where objects are floating around that are representing extraterrestrial technologies. We just need to use our telescopes and find out. In fact, we are not even the first to say that. Galileo Galilei said that 4 centuries ago, and he was put in house arrest. Today, he would have been cancelled on social media. Once I realized that we found an object from a technological origin that was produced elsewhere, I would not seek approval from anyone else. I don't need likes on Twitter. I just want to know what it is.
Okay, so we're planning an expedition to, as was mentioned in the video, to find these fragments, the relics of this meteor, and hopefully it will be done this summer. And we were able to use seismic data from the sound waves produced by the explosion, as recorded in a seismometer on Manus Island in Papua New Guinea. By fitting the signal, we were able to figure out what the distance was and pin down the location of the meteor explosion to within a kilometer. So now we are planning to go there, and I received full funding at $1.5 million for this expedition, and we hopefully will accomplish this task in the summer of 2023. Now, coming back to Oumuamua, the first reported object, it was really strange. First, it appeared from a very special frame of reference, which is called the local standard of rest, which is the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. And only 1 in 500 stars is so much at rest in that frame as Oumuamua was. And then the sun kicked it out of this frame, just like a big boat kicking a buoy on the surface of the ocean. As the object was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10, meaning that it has a very extreme shape, sort of like a piece of paper tumbling in the wind. And the most likely, at the 90% confidence, the most likely shape of this object was that of a disk, of a pancake, a flat object. And also this object was pushed away from the sun by some non-gravitational acceleration. And one might say, oh, maybe it's a comet, but the Spitzer Space Telescope looked very deeply around this object, and you can see the image on the top right, and didn't detect any carbon-based molecules or any dust. any vapor. So it didn't look like a familiar comet. We were able to put very tight limits on it. Now, people thought about exotic comets, like comets made of hydrogen or nitrogen that are not of the type that we are familiar with. And in fact, tomorrow there will be a paper in Nature magazine, in Nature, about another model suggesting it's a mix of water, ice, and hydrogen. But all of these models have problems. The hydrogen evaporates too quickly, so it cannot survive the journey. In nitrogen, there is just not enough nitrogen in solid form in the Milky Way galaxy. At any event, the explanation that I provided is that the push from the sun is coming as a result of reflecting sunlight. So for that, the object had to be very thin and sort of like a light sail, and nature doesn't make such objects. So as I mentioned briefly, there were suggestions that it may be a rock of a type that we've never seen before, and all of them have problems. The fundamental question is whether Oumuamua was natural or artificial. And of course, when we go to the beach, we often see rocks that are familiar or seashells, just like asteroids and comets in the solar system. But every now and then we see a plastic bottle, which may resemble Oumuamua, indicating that there is a civilization out there that produced it. Now, about 3 years later, in September 2020, there was another object discovered by the same telescope in Hawaii. It was given the name 2020 SO, and it exhibited the same qualities. It was pushed away from the sun by reflecting sunlight and didn't have a cometary tail. And then the astronomers realized it's actually a rocket booster that NASA launched in 1966. So we know that this one is artificial because we produced it. And the thin walls of this booster allowed it to be pushed by reflecting sunlight. It was made of stainless steel. The question is, who produced Oumuamua? And finding Oumuamua by astronomers is just like imagining a cave dweller that is used to playing with rocks. Imagine the cave dweller finding a cell phone. He would argue that the cell phone is a rock of a type that he had never seen before. And if he is an adult, he might just throw it away. But if this cave dweller has a kid, the kid may go after this special rock and press a button and then realize it's not a rock. I should say that Oumuamua inspired a special brand of wine, and also the following.
There we go. You are well in the lead at 4,400. How much would you like to wager? Let's do 2,000, please. Here's your clue. I look at the world and I notice it's turning, thanks to this man who studied at the University of Krakow in the 1490s. Who is Brahe? No, correct response. Who is Nicholas Copernicus? You lose a little bit. Pick again, Robin. Scientist for 600. We think of this Russian who became a professor of general chemistry in 1867 periodically. Robin. Who is Mendeleev? Yes. Scientist for 800. Avi Loeb thinks a space object seen in 2017 and artistically depicted here comes from this 16-letter type of being, the title of his book. Kevin.
What is extraterrestrial?
Correct.
Scientist for 1,000.
Okay, let's move on. This was Jeopardy, by the way, and I'll skip some slides so that we have time for questions. Another important development recently was that the US government is reporting that the military personnel are witnessing objects in the sky whose nature is unclear. They call them unidentified aerial phenomena, or UAP. And there were 2 reports by the US Office of the Director of National Intelligence to the US Congress in 2021 and 2022. And The question is whether these are human-made, and of course we all heard about the balloons that were shot down by the US government, but balloons make up about half of those unidentified objects. The question is there any one of them that may be of extraterrestrial origin? So that's the fundamental question, and the US government is very interested in that, and it established a new office to collect the data, and NASA also established a committee that will study those UAP and decide whether to allocate funding. So altogether, we, there is a convergence between the discovery of interstellar objects and also these UAP. And in a way, it's interesting to check if any of them might be of technological origin. So the next few years will be quite exciting. And the Galileo project is aimed at exploring exactly this issue that I just mentioned. Now, with respect to objects, the relevant equation is not at all similar to the Drake equation for radio signals, because here, all you care about is how many objects there are per unit volume. And then if you have a survey of a given volume, that gives you the number of objects that you will find. And if you are using the Earth as your detector, then it also depends on the speed of the object, because the flux of objects is the number density times the speed. And I would add one additional factor. Now, of course, we've been searching for objects that are rocks moving at very low speeds, 10,000 times slower than the speed of light. It could be that there are many objects moving very fast that we haven't noticed. Also, we can see the reflection of sunlight from objects as big as a football field or bigger, but not from smaller objects. So there might be a lot of smaller objects. In fact, we never launched a spacecraft as big as a football field. So all of that should be multiplied also by what I call the ostrich factor, because the question is whether we look. And if we don't look, we will not find anything. The likelihood of discovery depends also on us, not just on them. So let me skip some slides and mention that in the context of the Galileo project, we're also designing a space mission that will come close to the next Oumuamua and give us a close-up photograph. What you see on the right side is a photograph taken by the OSIRIS-REx mission, which landed on the asteroid Bennu. And you can clearly see that this asteroid is made of rocks. It's natural. So if we come close to an interstellar object like Oumuamua, we could tell if it's a natural object, or maybe it has bolts and screws on it and a label saying made on an exoplanet. And we already have a dating app for finding the next Oumuamua. It will start operations in a year. It's called the Vera Rubin Observatory in Chile that will have a survey of the southern sky every 4 days, and will have a camera with 3.2 billion pixels, 1,000 times more pixels than you have on your cell phone. And most of the time we will swipe to the left on this dating app, but we might decide to go after an object that looks as weird as Oumuamua was. And with the Webb telescope, we can look at the object from a different direction than from Earth. And it's sort of like having two eyes so that you can gauge the distance to an object. And we will be able to pin down the trajectory of the object in 3 dimensions very precisely this way. So I will skip some photographs and mention that the Galileo project is aiming at identifying the nature of those UAP, unidentified aerial phenomena, designing a space mission to date the next Oumuamua, and also going after the relics of an interstellar meteor, as we are planning to do this summer. We have a number of published papers that should come out next month. This is the observatory that we use for UAP, it basically monitors the sky 24/7 in the infrared, optical, radio, and audio. And that's a real image of a winter day near Boston where there is a lot of snow. But you can see the instruments. For example, this half sphere is a collection of cameras in the infrared that covers the entire sky. And next to it, you can see a fisheye lens of an optical sensor. We have radio sensors, and we have also audio sensors. So the idea is to monitor the sky and see if there is any object that is not human-made or natural. This is the infrared camera. We calibrated it. We also have an optical wide field camera, and this is an example for an image. And we also have a camera that zooms on an object of interest in the sky. And this is the acoustic system that measures sound waves from the infrasound to the ultrasound. And we have a passive radar system that hopefully will be able to pin down the distance to objects in the sky. We are also measuring the weather, the conditions in the atmosphere. And all the data is being transferred to an artificial intelligence software that classifies objects and decides whether they are natural, artificial, in other words, human-made, or perhaps something else. We also use data from satellites using Planet Labs data that can identify the motion of objects by looking at them from above, not just from below. And we are planning to make more copies of this first system in the coming months. So as you know, we don't know what the nature of most of the matter in the universe, and we call it dark matter. And many people quote Carl Sagan from the 1970s, who said extraordinary claims require extraordinary evidence. But my point is that extraordinary evidence requires extraordinary funding. We need to engage in the search, because saying we don't have the evidence is a circular argument. You will never get the evidence unless you invest in the search. And in the context of dark matter, we built a Large Hadron Collider in search for the lightest supersymmetric particle, and it cost us $10 billion, and we haven't found it. And that shows that the idea of supersymmetry in the parameter space that was envisioned is wrong. So that was a speculation that didn't have extraordinary evidence. So why did we invest $10 billion? Because science is done through searching for the truth. You don't know in advance what you might find if you are willing to uncover some new knowledge. So claiming that there is no evidence yet, and therefore this is an extraordinary claim, was definitely not the case for supersymmetry. And if we invest just 1% of that amount of money in the search for technological equipment from other civilizations, that's the budget that the Galileo project aspires to have, then we can answer this question. And what we might find could come in two forms. It could be space trash, meaning objects like Voyager 1, Voyager 2 that we launched, that within 1 billion years, they would be just dysfunctional and appear like space trash. Or we might find functional devices equipped with artificial intelligence. I call them AI astronauts. And by observing those packages in our mailbox, we might be learning about other civilizations that might be dead by now. They might not be around. So it's very different from looking for radio signals, because for that, it's just like waiting for a phone call. You need the counterpart to be active in order for you to get a phone call. We don't have a protocol for how to engage with a visitor in our backyard. And frankly, I think we should wait to figure out what this visitor entails before we make any plan. My hope is that if we find relics of a more intelligent species, it would inspire us to ignore the small differences among us and cooperate as equal members of the human species. Because most of the history of humans, most of the atrocities is when one group of people tries to feel superior relative to another group of people, which makes no sense in the big scheme of things. So if we look at the universe at large, we can think of it as a cosmic play that started 13.8 billion years ago. And the human species just came over the past few million years. That's really at the end. So if you arrive to a play and you only arrive at the end of the play and you are not at the center of the stage, the play is not about you. And that's a message that many humans have a hard time accepting. And when you tell people there might be other civilizations smarter than us, they immediately ridicule it and don't want to discuss it. And that's including academia. And it goes opposite to common sense. And what I find is that common sense is not common. Thank you. I'll be glad to answer any questions you might have. So let me stop sharing and you can go ahead and ask me questions. We have about 10 minutes.
Thank you for the lovely talk, sir. I'll ask the audience if they have any questions. So, yes, sir. Can you come up, please? Yes, sir. Can you come up, please?
Please go ahead. Any question?
Yes, sir. Yes.
Yeah, I can see you. You can speak. Go ahead.
Yeah, so thanks. It was a very nice talk. So I have a couple of questions. So first thing is that what is known about, so you mentioned this interstellar meteor 1 and 2.
Right.
What is known about the composition or possible composition about those objects?
Yeah,
Yes.
so all we know is that the meteor exploded about 10 kilometers above the sea level, above the Pacific Ocean. And we know the density of air at that location. We know the speed that the meteor was moving. It was moving very fast at about 40 kilometers per second. And so we can infer the stress on the surface of the object. It's called ram pressure. It's basically the mass density of air times the speed squared. That's the pressure acting on the object. And so we know that it was able to survive down to that lower atmosphere, and therefore it must have material strength, a yield strength above this value of ram pressure. And that value is 10 times higher than the material strength of iron meteorites. So all we know is that it was tougher than all space rocks that were in the catalog, and by a factor of at least 10. Okay. Now, what it's made of, we have no idea. So that's what the expedition is planning to do. We are planning to use a sled and a sluicing device to collect the fragments. Hopefully, we will find the millimeter-sized fragments from the meteor, and then we will pass them through an X-ray mass spectrometer and try to figure out what the composition is. And that will address your question. So at the moment, all we know is the material strength was unusual.
The second question is, so you mentioned the possibility of this AI-powered spaceship or some special object. So what is your theory about what will be the energy source or power source? How will it keep functioning through a long voyage?
Yeah, that's an excellent question. So I can think of various possibilities. First, you may have nuclear energy fueling the system the way we are using, like New Horizons used plutonium, and you can imagine something of that type. Or you could imagine harvesting energy from the environment and using it as fuel. It depends what the engine is like. And and also there may be technologies that we don't possess, that I cannot imagine. And just to give you, in fact, every couple of days I have an essay on Medium. This is an online site, and if you just put my name, Avi Loeb Medium, you will see that before this talk, just 2 hours ago, I posted an essay before my morning jog when I woke up today, and it was about exotic propulsion, methods for propulsion that could be quite unusual. One of them is the light sail that I mentioned in my presentation, but another one is another one has to do with gravity, and I talk about it, and there is a clickable reference for that, so you can find it. It's basically if a technological civilization is able to produce a negative mass object with a negative mass that can propel a spacecraft to arbitrary speed, I mean, as close as you want to the speed of light. And you can read more about it. It's based on a paper that was written in 1957 by Herman Bondi. So have a look at that essay from this morning.
Yeah, thank you.
Okay, sir, thank you. Does anyone else have any questions? Okay, sir, we have one more question.
Okay, please go ahead.
Hello, Professor. Thanks for
Hi.
the talk. I have one question on the Oumuamua that you said.
Yeah.
We do know that it's an interstellar object, and since we have not checked the composition of it, how are we sure that it is sort of an alien object? Like, why are we sure? Like, if it's an interstellar object, we don't know what are the compositions it can be made up of. It might be a natural meteorite.
Yeah, so definitely it could be natural, but it has anomalies. It doesn't look like the usual comet that we are familiar with. So, so it could be that both Oumuamua and the meteors that I described originate from a source that is very different than the solar system. That's why they have properties that are very different than asteroids or comets. It's possible that they are natural. But if they are, then we will learn something new about a new source of objects. And it could be, for example, a merger of two neutron stars that produces some very tough material, that we don't know about. It could be an exploding star. It could be something else. I cannot rule it out because we don't have good data. But all I can say is that Oumuamua did not look like a comet or an asteroid that we had seen before in the solar system. It looked unusual, and one possibility is that it was artificial in origin. And of course, science is driven by data, by evidence, and we cannot be sure until we get more evidence on objects like that. So the idea is to collect, I'm intrigued enough to collect more data. And if you ask other people, they would say, no, it's a rock, forget about it, let's move on, let's continue to work on rocks. And I say that's not the scientific approach. Science can be exciting. It doesn't have to be boring. It doesn't have to always be what we know from the past. And especially when dealing with the first objects that come from outside the solar system. Why? I mean, the universe is under no obligation to give us objects that are exactly the same as in the solar system. Most of the matter in the universe is dark matter. That's not the same matter that we find in the solar system. So why should we be so narrow-minded and say, oh, no, we know it. It must be rocks, just like we have in the solar. It's like saying you have your own backyard at home, and everything that you find in your backyard must represent the street that you live in. That's clearly nonsense. On the street, there are objects that you don't find in your backyard. So let's find out what they are. That's all I'm saying. And even just for saying that, there is a huge amount of pushback, and everyone wants to say, no, it's something like what we have already in our backyard. And I say, well, you are not curious enough.
Yeah, okay. Like one more follow-up on this one. Do we at present know the location from where that meteorite came? Like, have we figured it out yet?
Well, any direction on the sky coincides with the vicinity of a star, so it wouldn't tell us where it came from. It's very difficult to associate an interstellar object with a particular star because the size of the Oort cloud, the size of the solar system, is going halfway to the nearest star. So just imagine it's just like billiard balls that are densely packed, the Oort clouds of all the stars. So in any direction you take on the sky, you are intersecting a lot of those. You cannot tell which star it came from.
Yeah. Thank you.
You're welcome. So I think we are close to the time limit.
And I don't think there are any more questions either. So that just aligns perfectly. Oh, okay. We have one question, sir. I'm sorry.
Okay. So you have one more question?
Yes, sir.
Okay. So let's do it quickly, and that will be the
Yes.
last one. Okay, go ahead.
Professor, you said that the first interstellar object was discovered in 2014,
Yes.
but like that is from the time we were able to detect some things like this. What about a possibility like before this? Like,
Yeah, so that's a very good question. So the thing is, what was special about 2014 or a decade ago is that the US government established satellites and other sensors that are monitoring the entire Earth. And they did it, of course, for national security purposes. And that's the system that discovered this meteor. So it's actually the government that discovered it. It's not scientists, and we didn't have such a system before. Okay, and with Oumuamua, it was a survey telescope in Hawaii that discovered it. We didn't have that before. So only over the past decade we had the instruments that are capable of reporting about objects like that.
oh, thank you, Prof.
Okay. Thank you very much.
Yes, sir. We are glad to have you. And this was a part of a huge event called Cosmic Garage. I hope you can see written on the board there.
Yeah,
So,
I can see that.
Yeah,
yeah.
it's our club's annual festival sort of thing, and we are glad that you were here to conclude it for us. So we are again glad, and I'd like to thank you. Yes.
Thank you for hosting me, and I hope that one of you will be a discoverer of a future object from a technological civilization.
Yes, sir. I'm sure you sparked a lot of interest around here.
Okay.
Thank you.
Bye-bye.
Bye-bye.